Welcome everyone. In this video, I am going to talk about the very important chain rule of partial derivatives, and in the latter part I will also talk about higher order partial derivatives. So watch the video till the very end. In case if you are new to the channel, please subscribe it. So let's start first by discussion related to the chain rule. So what is chain rule? Suppose z is a function of two variables, that is x and y, and x further is a function of t and y is a function of t, and we have to differentiate z with respect to t. So what we have to do, we have to use chain rule in this case. So here we have the situation. I am writing z, which is a function of x and y, and x is a function of t and y is a function of t. Then z, if I substitute the value of x and y, which is in terms of t, will become a function of t. So how to find dz by dt? To find dz by dt, first of all we differentiate this function partially with respect to x, and then x being a function of t, I differentiate x with respect to t. Plus we also differentiate f partially with respect to y, and y being a function of t, I differentiate y with respect to t. I hope you might have noted that when I am differentiating f, I am differentiating it partially with respect to x and here partially with respect to y. But since x is a function of t, I am writing dx by dt, and y is a function of t, I am writing dy by dt. This idea can be extended to more number of variable. Suppose we have a situation where x is dependent on three variable, x, y and z, and further x is dependent on t, y is dependent on t, z is dependent on t, and suppose they ask us to find df by dt. So how can we find df by dt? First we have to differentiate f with respect to x partially and then x with respect to t. Then in the second we have to differentiate f with respect to y partially and then y with respect to t. And finally we also have to differentiate f with respect to z and z with respect to t. So this idea can be extended if a function is dependent on any number of variable, and that those variables are further dependent on some variable t, right? Now another important observation is that there may be a situation where we have a function z which is dependent on x and y, and x and y are further dependent on more than one variable, that is u and v, right? So here we have the situation that z is a function of x and y, and x is further dependent on u and v, and y is further dependent on u and v. And suppose we have to find del f by del u. So how to find del f by del u? Since f is a function of x and y, first I differentiate del f with respect to x partially and then x with respect to u, and plus we have to differentiate f with respect to y partially and then y with respect to u. So basically if I have to differentiate this function z, which is a function of x and y, z is a function of x and y. So if I want to differentiate it with respect to u, then I differentiate it with respect to x and x with respect to u, and I differentiate z with respect to y and then y with respect to u. Similarly, if I have to differentiate f with respect to v, then I hope you are smart enough to guess that using chain rule I have to differentiate f with respect to x first and then x with respect to v, and then f with respect to y and y with respect to v. So this is how it can be done. So we are going to take many problems, and this idea can also be extended, like z may be dependent on maybe the function may be dependent on possibly more than one variable. Suppose I say x, y and z, and further suppose it is dependent on u and v, and this is also dependent on u and v, and this is also dependent on u and v. So in this case, for example, if I ask you that what will be del f by del u, so you are smart enough to guess that first I have to differentiate f partially with respect to x and x with respect to u, then f partially with respect to y and y with respect to u, then f partially with respect to z and z with respect to u. So this is a chain rule because we are creating a chain of terms, that z with respect to x, x with respect to u, z with respect to y, y with respect to u, and so on. So to get it better, let us solve many problems. So the first problem is this. So here we have to find df by dt at the point t is equal to 0, where it is given that function is x cos y plus e to the power x sin y, x is equal to t square plus 1 and y is equal to tq plus t. So how to solve it? To solve it, first of all we have to evaluate it at t is equal to 0. So if I take t is equal to 0, what will be the value of x? I can get 0 square plus 1, that is equal to 1. And what will be the value of y? That is 0 cube plus 0, that is equal to 0. Now I have to find df by dt. So it means what? That f is a function of two variables x and y. So first we have to differentiate f partially with respect to x and then x with respect to t. Again I repeat here, when I am talking about x, x is just dependent on one variable, so that is why I am writing dx by dt. And same thing, that I have to differentiate f with respect to y partially and then y with respect to t. So what is del f by del x? Del f by del x, if I differentiate it with respect to x, then I will get cos y and plus here e to the power x will give me e to the power x, sin y is a constant to sin y, and then dx by dt, that will give me 2t, and plus del f by del y. So if I differentiate this with respect to y, x is a constant, derivative of cos y is minus sin y, so it will become minus x sin y and plus e to the power x, and derivative of sin y is equal to cos y. And then we have to differentiate dy by dt, so that will give me 3t square plus 1. Now we have to calculate this value at t is equal to 0. So at t is equal to 0, del f by dt. And see, one more thing, I think some of you might already have realized that this is a small thing that I can correct here, that when I am differentiating, the f will be a function of just one variable. So in spite of writing del f, we have to write df by dt, and here also in spite of writing del f, we have to write df by dt. I hope this point is clear to you. I realized it. So df by dt. Why? Because if you substitute in place of x this value t square plus 1 and in place of y tq plus t, so ultimately the f of xy will become a function of just t, right? So that is why we have to write df by dt. So now at t is equal to 0, if I take t is equal to 0, this whole expression times 0 will make it 0, so no need to worry about that, and plus now if I take t is equal to 0 here in this expression, I will get what? I will get this expression will become 1. So I have to look at this expression as well. So what is the value of x at t is equal to 0? This is 1. So I get minus 1 and sin y. So sin y 0, so this will become sin y 0, so sin y will become 0, and plus e to the power x, so I will get e to the power 1 cos y, so cos 0 is equal to 1, and then if I put t is equal to 0, I will get 1. So in the end what we get just e. So this is the value of df by dt at t is equal to 0. So this kind of questions may be asked in multiple choice exam as well. Let us take the next problem here, and here also we have a similar problem. So we have to calculate df by dt at t is equal to 0, where these are the functions. So first of all, we need to evaluate that what is the value of x, y and z at t is equal to 0. So at t is equal to 0, it is e to the power 0, that is 1. Y is equal to cos 0, so cos 0 is also equal to 1, and z is equal to 0 cube, so that will become 0. And we have to evaluate df by dt. So again, using the chain rule, I can write it del f by del x and then dx by dt, plus del f by del y and dy by dt, plus del f by del z and dz by dt. So this is how it should be written. Now what is del f by del x? So this is the function. So if I differentiate this with respect to x partially, x cube will give me 3x square. Then we have xz square, so that will give me z square. Y cube will give me 0 and xyz will give me x into z. Dx by dt, so x is equal to e to the power t, so this will give me e to the power t, plus del f by del y. So if I differentiate this with respect to y, the first term will give me 0, the second term will give me 0, third term will give me 3y square, and the last term will give me x into z. And dy by dt, so it is cos t, so it will become minus sin t. And the last term, we have to differentiate it with respect to z. So x cube will become 0, xz square will become 2xz, and y cube will become 0, and xyz will become xy. And if I differentiate it with respect to t, I will get 3t square. So at t is equal to 0, we have to evaluate this. At t is equal to 0, df by dt. So what I will get? See, here e to the power 0 will become 1, and let me write here 3 into 1, so I will get 3, plus z squared, so I will get plus 0, and plus xz, so x is 1, z is 0, so this will also be 0. E to the power t, so e to the power 0 will become 1, plus if I put t is equal to 0, then sin t becomes 0, so 0 into anything will become 0, so I directly write 0, and plus if I put 0 here, then again the whole expression will become 0, so I write just 0 here. So in the end we get what? In the end we get the value that is equal to t. So the value of df by dt at t is equal to 0 is equal to 3. So let us quickly solve this problem as well. So here we note that we have to find dw by dt. W is a function of two variables x and y, and x is a function of t, y is a function of t, and we have to evaluate this value at t is equal to 1. So first of all, let us evaluate that at t is equal to 1. What is the value of x? The value of x will be 1 square minus 1 by 1, so that will become 0. And what will be the value of y? The value of y will be 1 by 1 square plus 1, so I will get 1 by 2. Now we have to find dw by dt. So to find dw by dt, what we have to write? We have to write del w by del x and then dx by dt, plus del w by del y and then dy by dt. Now what is del w by del x? I have to differentiate this with respect to x, so I will get 2x dx by dt. So this thing, if you want to use u by v formula, fine, but this x can also be seen as t square by t can be written as t and minus 1 by t. So I separated that, t square by t minus 1 by t. So if I differentiate it with respect to t, I will get dt by dt is as 1, and d by dt of 1 by t is minus 1 by t square. So this will become plus 1 by t square, and then plus del w by del y. So with respect to y, I will get 2y, and dy by dt. So here I can use the u by v formula. So if I differentiate first denominator t square plus 1, and then d by dt of t minus t, and then d by dt of t square plus 1, and this whole thing is divided by t square plus 1 whole square. So this gives me what? This gives me 2x into 1 plus 1 by t square plus 2y, and t square plus 1 will give me t square plus 1 here, and dt by dt will become 1 and minus t, and it will become 2t divided by t square plus 1 whole square. So if you want to simplify it, fine, otherwise you could have directly put the value. So let me simplify 2x into 1 plus t square plus 2 into y, and t square plus 1 minus t2 2 into t square, so 1 minus t square I am getting in the numerator, and in the denominator I can write it 1 plus t square square. So at t is equal to 1, we have to get dw by dt. So at t is equal to 1, the x value is 0, so this whole expression will become 0. And at t is equal to 1, the y value is 1 by t, so I write 2 into 1 by 2, and then 1 minus 1 square, right? So if I put t is equal to 1, I will get this whole expression will become 0. So 0 plus 0, 0 plus 0, so the answer is equal to 0. So this is how we can evaluate the partial derivatives using chain rule. Now let us look at two such problems where we have to do the proving. So it is given that z is a function which is dependent on x and y, and we have to prove that b times del z by del x minus a time del z by del y is equal to 0. So it is given z is equal to a function ax plus by. So first of all, if I find what is del z by del x, so del z by del x will be what? It will be del by del x of z, which is f of ax plus by, and to differentiate this, first of all, this f is a function of ax plus by, right? So I have to differentiate it with respect to ax plus by, but I don't know what f is, so its derivative I'm just writing as f dash with respect to ax plus by as f dash ax plus by. But since I have to differentiate it with respect to x, I need to differentiate ax plus by also with respect to x, so that will give me a, right? And if I ask you what is del z by del y, so here also I will write del by del y of f of ax plus by, and I have to differentiate it with respect to y. So first I have to differentiate it with respect to ax plus by. So again I don't know what is the function f, so I just can write as f dash ax plus by, and ax plus by again with respect to y will give me b. So you can clearly see that if I call this expression as 1 and this expression as 2, if I multiply this by b, so b times del z by del x minus a times del z by del y. So what I will get? From the right hand side I will get a into b f dash ax plus by and minus a into b f dash ax plus by. So you can clearly see that this term and this term will cancel, so what I will get is equal to 0. So this is a very simple problem. It can be asked in a multiple choice question as well. Let us solve this problem, and after that we are going to talk about the higher order partial derivative. See, some of you after learning the Euler's theorem for homogeneous function can do it in an easier way, but since still we have not introduced the Euler's theorem for homogeneous function, I am not considering that result. I am going to solve it by the regular process. In the coming videos you will see that there is a function, there is a formula that is known as Euler's theorem, and which is a very popular result, that can help us to solve this problem in an easier way. But without using the Euler's theorem also we can solve it. So we have to prove that x times del z by del x plus y times del z by del y is equal to this. So first we have to find del z by del x, right? So what is del z by del x? You can clearly see that I can write del by del x, and this is a function of log. So using the property of log, this expression can be written as log of x square minus y square and minus log of x square plus y square. This will make the computation easier, but otherwise I could have done it without using the log also. So what is the derivative of log of x square minus y square? I have to differentiate it with respect to x partially. So first I have to differentiate it with respect to x square minus y square. That I will write 1 by x square minus y square, and then x square minus y square with respect to x, so I will get minus 2x. And here again I will get 1 by x square plus y square, and x square plus y square with respect to x will give me 2x. And if I ask you what is del z by del y, so I don't think you will have any trouble answering this. So you can write del by del y log of x square minus y square minus log of x square plus y square. So this will give me what? Again I will get 1 by x square minus y square, and del by del of this will give me minus 2y, and minus 1 by x square plus y square, and del by del y of this will give me 2y. Now I have to multiply this expression by x, so x del z by del x, and this expression by y, so plus y del z by del y. So if I have multiplied by x in the left hand side, I need to multiply by x in the right hand side. So from here I will get 2x square by x square minus y square, and here I will get minus 2x square by x square plus y square, and then I will get minus 2y square by x square minus y square, and then minus 2y square by x square minus y square. I think there is some x square plus y square that I will get here. Okay, so how to simplify? You can see that we have the term here x square minus y square, and we have the term here x square minus y square. So from this I can take 2 by x square minus y square common. So in the bracket I will be left with x square minus y square, and we have the term here like I can take minus 2 by x square plus y square common. So in the bracket I will get x square plus y square. So this term here x square minus y square and x square minus y square cancel, this term and this term cancel. So what I get is 2 minus 2. So 2 minus 2 I will get is equal to 0. So this is how we can prove this. Now let us talk about the higher order derivatives. So there is nothing special about higher order derivative. We already have talked about higher order derivative in case of single variable in your previous classes. So on the same line we can also talk about higher order derivative in case of function of two variables. So how it is defined? So to understand it, suppose I write that z is a function of x and y of two variables, then its second order partial derivatives are defined as follows. So let me write it. So suppose I have to find del 2f second order partial derivative of f with respect to x. So this will be given by what? This will be nothing but this will be del by del x of del f by del x. So this is how we define it, and it is also written as f of xx, right? The partial derivative of f with respect to x twice. So this is how it is also represented. If I ask you what is del 2 f, not y, sorry, del 2 f, because I am differentiating the function f. So del 2 f by suppose I ask you del y del x. So how it will be defined? As you can see, it will be defined as del by del y of del f by del x. So you can see that when I am writing it in this order, it is like del y and then del f by del x. So del 2f by del y del x is first we have to differentiate it with respect to x, and then del f by del x with respect to y, and this will be in shorter notation, will also be written as f of yx. Similarly, we can also define del 2f by del x del y. So you are smart enough to guess that this time it will be del by del x of del f by del y, and in shorter notation it will be written as x f of xy, and del 2f by del y square can be written as del by del y of del f by del y. So this will be written as f of yy. Okay. So here the derivatives, these derivatives and these derivatives, where I have differentiated with respect to x and y both, they are known as mixed derivatives. So they are known as mixed derivative, this term, and this term is also known as the mixed derivative. And if f of xy and f of yx are continuous at a point xy, then at this point f of xy and f of yx are equal. So in general, if I can write this statement, and there is a very important result. See, f of yx and f of xy will not always be equal, but this is a important remark. I am writing it, that if f of xy and f of yx are continuous at a point p x comma y, then at this point this f of xy is equal to f of yx. So this is how it should be looked at. Now to understand it better, I am going to take this problem, and here I am going to find all first order partial derivatives. So it is a kind of problem which will involve two different functions, that is ln x square plus y square and tan inverse y by x, and it is given that x comma y is not equal to 0 comma 0, because at this point if you take x comma y is equal to 0 0, this will become undefined. So we have to find all second order partial derivative. So it will be a kind of time consuming problem, so be careful to understand it. So we have to find what? Actually we have to find f of xx, we have to find f of xy, we have to find f of yx, and we also have to find f of yy. So to find all of it, first of all we have to find f of x. So this is the function, and I'm writing it directly now. So if I differentiate this function with respect to x, ln x square plus y square, so that will give me 1 by x square plus y square, and then x square plus y square with respect to x will give me 2x, and plus I have to differentiate this with respect to x. So tan inverse will give me 1 by 1 plus y square by x square, and then we have to differentiate y by x also with respect to x, so that will give me minus y by x square. I hope you know how to differentiate. So this will give me what? This will give me 2x by x square plus y square, and here we will have x square in the numerator, so it will cancel, and I will get 2x minus y. I have written it directly here, that this will go into the numerator, so denominator will become x square plus y square, so I will get 2x minus y, x square plus y square. If I get f of y, then what I will get? I will again get 1 by x square plus y square into 2y, and plus this will give me 1 by 1 plus y square by x square, but this time I have to differentiate it with respect to y, so y by x, so 1 by x will be the constant term. So what I will get this time, here if I take x square in the numerator, I will get x, right? So and here I have 2y, so I will get 2y plus x divided by x square plus y square. I hope it is clear to you. Now we have to find f of xx. So f of xx means what? That partial derivative of f of x with respect to x again. So I have to find del by del x of this thing, that is 2x minus y by x square plus y square, and this time I have to use u by v formula. So I write x square plus y square and then del by del x of 2x minus y minus 2x minus y, and then del by del x of x square plus y square, and this whole thing is divided by x square plus y square square. So what will I get? I will get x square plus y square. Del by del x of 2x will give me 2 and minus 2x minus y, so this will give me 2x divided by x square plus y square square. So if I simplify it, I will get what? I will get, let me write, otherwise you will be confused. So I will get here 2x square and plus 2y square and minus 4x square, and this minus plus, so plus 2xy divided by x square plus y square square. So I will get 2y square minus 2x square and plus 2xy. Yes or no? So how much in total we will get? There is some issue here. No, it's fine. So here we have 2y square minus 2x square plus 2xy, and this whole thing is divided by x square plus y square square. So what we have got is f of xx. Now suppose I want to get f of xy, right? So this is basically what? This is basically del by del x of fy. I hope you have seen that. Let me show you this expression, f of xy. So first with respect to y and then with respect to x. You just remember it this way, that if you have to get f of xy, then you start from the right. So first with respect to y and then with respect to x. So I will write del by del x, and what is fy? So fy is 2y plus x by x square plus y square. So I write 2y plus x divided by x square plus y square. So let us use the u by v formula. So x square plus y square del by del x of 2y plus x minus 2y plus x del by del x of x square plus y square, and then this whole thing is divided by x square plus y square square. So just to save space, I am writing starting from here. So what I will get? I will get x square plus y square, and del by del x of this will give me 1, and minus 2y plus x, and del by del x of x square plus y square will give me 2x and divided by x square plus y square square. So if I simplify x square from here and minus 2x square from here, so I will get minus x square and 4xy, right, and y square. So I write y square minus x square and minus 4xy divided by x square plus y square square. I hope you got it. This term will give 4xy with a minus sign, and this term will give me 2x square and with a minus sign, but x square with a plus sign, so I will get x square with a minus sign, and y square. So y square minus x square minus 4xy whole square. So this is what we will get. Now let us calculate f of yy. So f of yy will be del by del y of f of y. So del by del y of, and what is f of y? That we already have written here, that is 2y plus x by x square plus y square. So this time I am going to write it directly, x square plus y square and derivative of 2y plus x. So derivative of 2y plus x with respect to y will give me 2. Derivative of this minus 2y plus x, and derivative of x square plus y square with respect to y will give me 2y, and this whole thing is divided by x square plus y square whole square. So this will give me what? 2x square from here and 2y square from here and minus 4y square. So this will minus 4y square, this is 2y square. So I will get how much? 2 times let me write it. So 2 times x square plus 2 times y square minus 4y square, and then minus 2xy. This whole thing is divided by x square plus y square square. So 2y square plus not 2y square, 2x square, because y is coming with a negative sign, so I will write it later. So 2x square and then minus 2y square minus 2y square, and then minus 2xy divided by x square plus y square whole square. Okay. Okay, so finally let us calculate f of yx. So f of yx is del by del y of f of x. So del by del y of, and what is f of x? F of x is 2x minus y by x square plus y square. So 2x minus y by x square plus y square. So I am going to write it directly, x square plus y square, and derivative of 2x minus y with respect to y, so I will get minus 1, and minus 2x minus y, and derivative of x square plus y square with respect to y will give me 2y, and this whole thing is divided by x square plus y square square. So this will give me what? This will give me minus x square minus y square minus 4xy and plus 2y square divided by x square plus y square whole square. So if I simplify it, 2y square minus y square is y square minus x square minus 4xy and divided by x square plus y square square. So you can see that the f of xy, I got y square minus x square minus 4xy, and f of yx I also got the same thing. So if the function, because here f of xy and f of yx both are continuous, so that is why we are getting them to be equal to same. Okay, so I hope you are not losing concentration. So I am going to discuss this very interesting and important problem, and I have taken it just for your understanding. So in case if you are watching the video with a pen and paper, I would suggest you to pause the video and try to solve it yourself first, and then see whether you are able to solve it or not. So it is given that x to the power x, y to the power y, z to the power z is equal to c. We have to prove that at point x comma y comma z this will be true. So let us solve it. X to the power x, y to the power y, z to the power z is equal to c. So to solve it, first of all I take log in both sides. So the what I will get is, I will get x log x, I will get plus y log y, and I will get plus z log z is equal to log c. And we have to find del 2z by del x del y, means I have to keep the z as the dependent variable, which depends on two variable x and y. So for that, what I do, I take z log z here, and I take all the things in the right hand side, that is log c minus x log x minus y log y. And first I have to differentiate it with respect to y and then with respect to x. So I differentiate both sides with respect to y first. So del by del y of z log z. Now if I am differentiating with respect to y, log c is a constant, so it will become 0, and derivative of x with respect to y will also give me 0. And here I will just have minus del by del y of y log y. I hope you are clear that here z is a function because I want to treat z as the dependent variable which depends on x and y. So z is a function of x and y, so it is not like if I differentiate z with respect to y it will become 0, right? So I hope you are getting it. Now here I have to use the product rule, so I will write z and then del by del y of log z and plus log z and del by del y of z, not del y. So del by del y of z. Okay, and in the right hand side we have minus, I take y, I take del by del y of log y, then I take log y and del y by del y. So this will give me what? Z del by del y of log z. So again, first I have to differentiate this with respect to z. So I will get 1 by z, and then I will write del z by del y. Okay, and here we have log z, and I will write del z by del y, and this is equal to minus y into 1 by y plus log y. Del y by del y will become 1, so this cancel. So 1 plus log z will be the common term, and here I will have del z by del y, and in the right hand side I have minus 1 plus log y. So this will give me del z by del y is equal to minus 1 plus log y divided by 1 plus log z. So this is the first thing. Now I have to differentiate it with respect to x. So del 2z by del x by del y. So that I have to find del by del x of, and this is with minus sign, so I take minus outside, and then we have 1 plus log y by 1 plus log z. So 1 plus log y divided by 1 plus log z. So the important thing here is that since I am differentiating it with respect to x, the y term will be treated as constant. So I write 1 plus log y out and minus del by del x of 1 plus log z to the power minus 1, right? So to simplify, minus 1 plus log y, and derivative of this will be like minus 1 plus log z to the power minus 1, that is minus 2, and 1 plus log z with respect to x. So first 1 plus log z with respect to z, that is 1 by z, and then del z by del x. So this will become what? Minus minus plus, right? And I will get 1 plus log y divided by 1 plus log z whole square into 1 by z del z by del x. So this is what we have got. This is the value of del 2z by del x del y. But we have to evaluate at x is equal to y is equal to z. So at x is equal to y is equal to z. So if I take del 2z by del x del y, I will get what? And one more thing I want you to note, that del z by del y is minus 1 plus log y by 1 plus log z. So similarly, I hope you understand that if I have differentiated this with respect to y first, I am getting this. If I differentiate this with respect to x, then using the symmetry I will get minus 1 plus log x divided by 1 plus log z, right? Because this is symmetrical. I hope you understand that if I have differentiated it with respect to y partially, I have got this. With respect to x, I will get. So in the expression that actually we have to consider x is equal to y is equal to z. So I will get what? I will get 1 plus log y. So I will write log x because in the end I want the answer in terms of x in the right hand side. So everything I am changing it in terms of x, and minus by 1 plus, in place of z also I will put x. So I will get log x square 1 by x, and del z by del x. So del z by del x at z is equal to x. If you put z is equal to x here, so at x is equal to z, what will be del z by del x? So del z by del x will be this x and z will cancel, so it will be getting minus 1. So here for del z by del x I have to write minus 1. See, there will be a mistake some of you may make here, and the mistake that you may make here, that in place of z you can directly put x, which will be a mistake, and you will consider del z by del x will become 1. No, first we have to evaluate del z by del x, which I have done here in this step, and if I put x is equal to z, I am getting minus 1. So that is a point which I wanted to highlight. So in the end this log x and a square will cancel. So what I will get? I will get minus 1 by x, and 1 plus log x can be written as log e plus log x, right? So this will become what? This will become minus 1 by x and log ex. So that will be like minus x log ex whole to the power minus 1. So this is what we wanted to prove here, that minus x log ex whole to the power minus 1. And here I have got the same thing. If I take it in the numerator, I will get the power minus 1. 1 can be written as log e and log x. So using the property of log, it can be written as log ex. Okay. So this is what we have discussed in this video. I have discussed about partial derivative using chain rule. We have discussed a lot of problem. The last problem and the previous problem that I took was slightly time consuming, but I hope you have understood it. In case if you have any doubt, please put your doubt in the comment section. And what you can do at a particular point, if you want to put the doubt, you put the time stamp that I have the doubt at this point, so that I can see that what actually you are not able to understand. So thanks for watching. Have a great day. In the next video, I'll be talking about change of variables.